Jesus Christ. That is a server deployment, hot swapping the server-side code, and automatically updating the HTML the user has on their existing page. Oh boy, this is going to be a fun one. The main reason we're here isn't actually Elixir or even LiveView. Something different. It's JSON. Specifically, it's how much we hate JSON. It's not the right way for servers to tell clients what they should do, or most importantly, what they should look like. And we've realized this with everything from HTMX to React server components, that the server should do a little bit more to tell the client how the UI should look and also how to change that appearance over time. We realized this as well in the Elixir world, which, if you're not already familiar, was very similar to the Ruby world. With Ruby and Rails, we had Elixir and Phoenix, which very similar in design. But with Phoenix, we needed a way to not just send an HTML template, but update it as the user interacted. For a while, the solution was just embedding React and sending JSON back and forth, but that wasn't great. As a result, we went through some chaos inventing new solutions. One that I used for a while was Plug, which is still part of Phoenix to this day and had the ability to upgrade to a WebSocket connection so you could send updates via WebSocket to change the contents of the page. Really cool stuff, but what we're here to talk about today is a lot further and also took a lot of time. I was shipping the Plug stuff I just mentioned in 2017, but I had been hearing rumblings of some new developments. At the time, LiveView had just started in early 2018, and the progress they've made since in the last 6 years is nuts, resulting in a final, after so long, 1.0 release. What the hell is LiveView? Why do we want this? What are we even talking about? Don't worry, we'll break it all down. I will say though, this marketing speak is something I wholeheartedly believe. With Elixir, you start shipping features that other platforms can't even conceive as possible. The power of Beam. Y'all are gonna hopefully get something good out of this, even if you're not already an Elixir user or nerdy about it. I'll do my best to distill the cool lessons here such that we can all benefit from them. LiveView 1.0 RC0 is out. This 1.0 milestone comes almost 6 years after the first LiveView commit. Make it so. October 18th, 2018. Okay, not early 2018, but I swear I remember this being referenced a lot earlier on. Regardless, why LiveView? I started LiveView to scratch an itch. I wanted to create dynamic server-rendered apps without writing JavaScript. I was tired of the inevitable ballooning complexity that it always brings. Yeah, client-side JS isn't the worst, but I understand wanting to avoid it. Most other solutions were saying, oh, we'll just use WASM and we'll throw Rust in the browser to do all the updates. And we've seen how that works. Nobody's using it to this day. LiveView went a different approach. It was trying to transport data in a different way to and from the client. Think real-time form validations, updating the quantity in a shopping cart, or real-time streaming updates. Why does this require moving mountains to solve in a traditional stack? This is something a lot of the old guard doesn't acknowledge. All of the people who love to shout that Rails is totally fine pretend that these problems either aren't real or aren't worth solving. And I see this so much. Like one of the email clients that I won't say the name of that is written in Rails might seem great if you live near the servers it's hosting, but as soon as you go somewhere else, your experience sucks. And it doesn't do any of these types of things. It doesn't do validation of any meaningful form. But we expect this now for modern web applications. If everything's on the server, it's not easy to do that properly. And I'm thankful that the Phoenix community, unlike those other communities, doesn't just acknowledge this, but works hard to solve it. So this is how the solution used to work, is what I'm assuming we're about to talk about. We would write the HTTP glue or GraphQL schemas and resolvers. Then we figure out which validation logic needs to be shared or duplicated. It goes on and on from there. How do we get localization info to the client? What data serializers do we need? How do we wire up WebSockets and IPC back to our code? Is our JS bundle going to get too large? I guess it's time to start turning the Webpacker parcel knobs. Wait, Vite's a thing now? Oh, I guess bun configuration is what we want. We've all felt this pain. I like this part. I like the fact that we're making a lot of progress in the web world. I get it though. If you're just trying to ship and you don't want to look for new solutions, you just want to get something out, I can totally understand why this is frustrating. The idea was, what if we remove these problems entirely? HTTP can go away, and the server can handle all of the rendering and dynamic update concerns. It feels like a heavy approach, but I knew Elixir and Phoenix were perfectly suited for it. Bold, but exciting. 6 years later, this programming model still feels like cheating. Everything is super fast, payloads are tiny, latency is best in class. Not only do you write less code, there's simply less to think about when writing features. This sound familiar? If you're not already familiar with Intercooler, it's the original version of HTMX. Same project, same people. This is an article from their old website. I've already done a video about this, but I wanted to highlight this part because it's very similar to the mindset that we're seeing with LiveView. In an ideal world, you would give your UI devs everything they could possibly need to build their UI efficiently, an open and expressive query layer that would let them tune their structure and return the data of a query just so for those hot, complicated queries that always end up dominating performance. What if I told you that the place exists already where you can do this? Such a place does exist. It's called the server side. The whole point with this article is to point out that if you just do everything on the server and send the result to the client instead of building an API so the client can turn the data into UI itself, makes everything much more secure, much simpler to work with, and more trusted. It solves so many problems. If you can move more logic to the server, everything gets easier. And it's not just like your clients can be dumber apps or performance is better for low-end phones. And it's certainly not the other side people love to complain about of, isn't it so expensive to render that React on the server instead of the client? No, none of that is the thing that matters here. It's the simplicity of the model by moving so much state and problem space out of the client, which you don't own. You might have built it, but they could be on an old version. They could have a bad internet connection. There could be so many things that keep you from really controlling that. By moving this logic to the server, life gets better. And if you can do this, you almost always should. Anyways, let's hear more about how Phoenix and LiveView are doing this. Real-time foundations unlock superpowers. Interesting things happen when you give every user and UI a real-time bidirectional foundation as a matter of course. You suddenly have superpowers. You almost don't notice it. Being freed from all the mundane concerns of typical full-stack dev lets you focus on just shipping features. And with Elixir, you start shipping features much faster than any other platforms could even conceive as possible. Yeah, as the TypeScript guy that hasn't shipped much Elixir for the last 6 years, I still long for this. It has some magical stuff. Want to ship real-time server logs to the JS console in dev? No problem. Look at that. We're getting all of that. What about supporting production hot code upgrades when browsers can auto re-render anytime CSS style sheets, images, or templates change without losing state or dropping connections? Well, here's the terminal. We're deploying this on fly. We have this page already open, and it changes the CSS and changes the title on the page. Just deploying the new release is enough to send a WebSocket update to the page with the new content. That's insane. That's actually insane. Like for context, to see how Vercel solved this, they went the other direction. Vercel's solution is SKU protection, where when you deploy a new backend, they keep the old one around so that people who are on the old client can hit the old backend, which is insane. I think this is a great solution for the problem that exists with the modern server-client relationship. But what Elixir is doing is so much cooler because you can swap the code running while it's running because Elixir is running in a virtual machine. So rather than taking down the server and deploying a new one or rerouting traffic to a new server, you just change the code that's running in the existing instance, guaranteeing nothing falls out of sync. SKU reduction guarantees it the other way by making sure the client always has a server version that's accurate. This allows you to update the server's code without updating the server itself and then push any changes to the client as needed. Insanity. So cool. Or maybe you have an app deployed planet-wide where you do work across the cluster and aggregate the results in real time back to the UI. Would you believe the entire LiveView, including the template markup and RPC calls, is 350 lines of code? Oh, cool. There's sound here. Let's give this a quick play.
Don't do it. Starting browser, awesome. So what's happening here? Like we're provisioning a machine. We're running your whole app there. We're starting the app, loading page, loading page, loading page. It booted headless Chrome. It's running the web page. We're sending messages back as this is happening. And this just did this across the world. Like what? Like really? Like, yeah, so this is what Flame enables for us, right?
Super, super cool stuff. Let's take a look at the code quick so we can emphasize just how absurdly dope this is. Here's the page speed live test code. So we have this template. This is their syntax for HTML templating. In your editor, this looks a lot better, I promise. Probably the biggest negative with something like using Elixir is that your experience deep in like GitHub and such isn't going to have as good of like syntax highlighting and things just because it's not as popular. It's a very small thing, but notable when you're doing a lot of code reviews. Also, you might have noticed the Elixir community, big fans of Tailwind. Some of the heaviest Tailwind users I know come from the Elixir world. So this part will at least look familiar for us Tailwind devs. This is really cool where if there is no ref, then we use padding 36 and padding top 48, because this is for if we're putting like the empty state, I'm assuming. Otherwise, it's PY6, XL, PY12. And in here, we have a world page speed test title. You get all of this. All this code is just HTML markup. None of that's the interesting part. This is where things get interesting. Mount, we have the default URL, and we have the socket. So we take the socket, we assign the URI for this, and we bind it to a specific form. We stream the results down, and we do it with the specific IDs, because we're updating these specific IDs, timing dash specific region, and we stream the timings over. And then this is the syntax for a response being okay that makes it easier to handle errors in this language. Then we have the simulate result code where we create the timings array, which has all of the browser.timing statuses within it. We assign this list to the form again, and then we stream the results. Handle event. This is also, if you're not familiar with Elixir and pattern matching, part of the magic of Elixir is you can define the same function with the same number of arguments multiple times, but you match it in the argument based on condition. So this handle event gets called when the first argument is the string reset. This one gets called if the first argument is validate. This one gets called if the first argument is go. And this one gets called if the first argument is the constant of timing. And then this one is the generic if we still have a loading constant in the next object. And we have almost certainly a catch-all of some form. And if we don't, then we're expecting everything to go through and fall into this handle info, which is the error case. But this is part of the magic of Elixir, is you just write the same function and define the specific patterns you want to match with that function instantiation. These overloading patterns are so cool. And I've yet to experience a day where I don't miss these some amount. So cool. We can see if we have the loading state, then we stream and insert for the timings for that. This syntax, I'm not necessarily sure what it's supposed to be, so I will skip that for now. I think this is just sending the different results depending on the different loading states. And we ensure the URL has a protocol and a default to HTTP if we forgot to put one in. Cool. Then this actually does all of the timing and validates the URL. Here's where we actually load in Flame, which lets you spin up separate instances. It's a cool thing they're doing over at Fly. And now these are going to go spin out, do timings, send the requests, load the page, and then if it succeeds, we're going to send back up to where we are right now, which is this instance, the timing from that result. So this lets us run all of our tests and all of our checks to get the page load times on a separate server entirely without blocking this one, and then send the results back. All possible because Elixir's virtual machine handles networking insanely well. Here we have the status text, which is just the different cases. Isn't this so cool? Status text is a function that this is effectively like a big switch statement that says if the status is loading, we show loading page. If status is awaiting session, we do starting browser. If it's error, fail to load, or then we get the stat, then we can print out that stat and say complete. This is such a cool syntax. I love it. Yeah, the results all make a lot of sense. You can also see in here that we have little conditionals like if timing transferred bytes is greater than 0, then we render this. And if we don't have this if pass, it doesn't get rendered. There's a lot of these little syntactical things in here that don't take too long to learn, but are important to know if you're looking through stuff like this. Super cool stuff. I love that they shared this code. I think it's a really compelling example. There was a lot to solve to make this programming model truly great. As someone who consumed it very early, I agree. How it started. Conceptually, what I really wanted is something like what we do in React. Change some state, our template re-renders automatically, and the UI updates. But instead of a bit of UI running on the client, what if we ran it on the server? The LiveView could look like this. Here we have div ID thermostat. Temperature is bound to the thermostat temperature variable. Mode is bound to thermostat mode. Then we have the increment and decrement buttons. Now on mount, thermostat is thermocontrol.getThermostat. Okay, thermocontrol.subscribe. And if it's not okay, we would throw here. And then okay, assign, socket, thermostat. Dope. Def handle info. This is when new thermostat information comes in, because this is on mount getting this thermocontrol to bind to this instance. And we want this to send updates when things change. So the handle info is where those updates go, and we can do what we want here. In this case, we're going to assign the socket to the new thermostat information. So this gets sent down to the socket. Then we have the handle event where we can increment in this case, because we bound the phx click to inc, which means that when you click this, it's going to call handle event with inc as the first key. With thermostats, thermocontrol.increment socket assigns thermostat. Super simple. And you can immediately see how quickly decrement would make a lot of sense here too. Like React, we have a render function and something that sets our initial state when the live view mounts. When state changes, we call render with the new state in the UI is updated. Interactions like phx click on the plus or minus button can be sent as RPCs from client to server, and the server can respond with a fresh page of HTML. These client-server messages use Phoenix channels, which scale to millions of connections per server. Can confirm, Phoenix channels scale insanely well. Likewise, if the server wants to send an update to the client, such as another user changing the thermostat, the client can listen for it and replace the page HTML in the same fashion. My naive first pass on the Phoenix LiveView.js client looked something like this. We have the document query selector, we have the channel that we're getting a socket for from the server, channel.join, and then when we receive OK, we just update the HTML. Channel.onUpdate, HTML, main.innerHTML is HTML. Then we add an event listener. When we click on something that has a phx click attribute, we push this event up to the server, and eventually we'll get a response, and we use that response to update the HTML. Super, super simple. This is a super minimal implementation that I can fully understand how it works. Really cool that they published that in here. This is how LiveView started. We went to the server for interactions, re-rendered the entire template on state change, and sent the entire page down to the client. The client then swapped out the inner HTML. It worked, but it was not great. Partial state changes required re-executing the entire template and sending down gobs of HTML for otherwise tiny updates. No way other modern frameworks do that still, right? Right? I'm in pain. Still, the basic programming model was exactly what I wanted. As HTTP fell away from my concerns, entire layers of full stack considerations disappeared. HTTP is such a shit standard. I don't know why it's used for everything. Next, the challenges were making something that is truly great. Little did we know we'd accidentally our way to outperforming many SPA use cases along the way. Yeah. How we optimized the programming model. LiveView's diffing engine solved two problems with a single mechanism. The first problem was only executing those dynamic parts of a template that actually changed from a previous render. The second was only sending the minimal data necessary to update the client. It solves both by splitting the template into static and dynamic parts. Consider the following LiveView template. Okay, I have to jump on this. It seems like we're all realizing this, that having one HTML file is not the right solution to a lot of the problems we have on the web. A page like this might have this top nav be static, but the content of the blog might be a bit dynamic. Maybe the blog is static, but how recently it was posted is dynamic, or the comment section is dynamic. How do we have a partial template where we have HTML that represents everything that is always true, but then have pieces within it that aren't? And what if we have a dynamic piece that has a static piece inside of it? How do we structure all of this? With React, the new model is server components and client components, where the server components, the static template-y part, and the client components are the dynamic changing at runtime part. In Elixir, they're doing this a little differently. Consider the following LiveView template. P class is at mode, temperature, format unit, etc. Cool. At compile time, we convert the template into a struct as follows. We have the static part, which is the P class, temperature, etc. Or the dynamic part, which if changed, assign mode, do assigns.mode. If changed, assigns temperature, do format unit, assigns.temperature. Interesting. We know the static parts never change, so they are split from the dynamic Elixir expressions. Next, we compile each expression with change tracking based on the variables accessed within each expression. On render, we compare the previous template values with the new and only execute the template expression if the value has changed. This is like quick but good, and it's solving real problems. Instead of setting the entire template down on change, we can send the client all of the static and dynamic parts on mount. After mount, we only send the partial diff of dynamic values for each update. To see how it works, we can imagine the following payload being sent on mount for the template above. We have S, which is static, P class is yada, temperature /P. And we have the dynamic value of cooling and 68 degrees Fahrenheit. And the reason these are replaced where they are is because the separations of the array are where these go. So you insert between index 0 and 1, dynamic value 0, and you insert between 1 and 2, dynamic value 1. Where this gets iffy is if you have nested dynamic values. I'm sure they have a good solution though. The client receives a map of static values in the S key and dynamic values keyed by their index in the statics. For the client to render the full template string, it only needs to zip the static list with the dynamic values. Yeah, you get the idea. You just zip it in between the spots. With the client holding a static and dynamic cache, optimizing network updates is no work at all. Any server render following the mount simply returns the dynamic values at their known index. Unchanged dynamic values and static values are ignored entirely. If a LiveView runs assign, like here with socket temperature 70, the render function is invoked, and the following payload gets sent down to the wire. That's so nice. Somebody said in chat, and I love that. This is the world's best zip use case so far. Totally agree. To update the UI, the client simply merges this object with a static and dynamic cache. Cool. So this gets thrown in here and updates the UI accordingly. Then the data is zipped together on the client to produce the full HTML of the UI. Of course, inner HTML updates blow away UI state and are expensive to perform. So like any client-side framework, we compute minimal DOM diffs to efficiently update the DOM. In fact, we've had folks migrate from React to Phoenix LiveView because LiveView client rendering was faster than what their React app could offer. Very interesting. I might have to listen to that podcast in a bit. Regardless, it's kind of crazy, but also cool that they had to implement their own virtual DOM in order to trigger the right updates in the right places. Optimizations continued from there, including fingerprinting, for comprehensions, tree shaking, and more. You could read all about these optimizations on the Dashbit blog. Good shit. We apply these optimizations automatically and for free thanks to our stateful client and server connection. Most other server-rendered HTML solutions send the whole fragment on every update, or they require users to fine-tune updates by hand. This is even more true in the Ruby world, where their solution to client-side navigation experience was a thing called Turbo. And Turbo just loads the whole HTML page when you make changes, and then client-side swaps out the HTML, breaking a ton of shit almost every time. It's why navigating GitHub still feels like shit to this day. This is not a real solution. And I'm pumped that they not only acknowledge that, but went out of their way to work beyond it. Best in class latency. We've seen how LiveView payloads are smaller than the best handwritten JSON APIs or GraphQL queries, but it's even better than that. I want to double down on this part before we go further, though. Everyone seems to think sending HTML is somehow less efficient than sending JSON or GraphQL calls. I promise you, almost every JSON call or GraphQL call is both fetching way more data than it needs and is not structured in a way that's optimal for what the UI actually wants in the end. I don't need all of the info about a user in order to render a username. I just want the username. And if the API endpoint gives me all this additional data, it's useless to me. Well, it's useful because I have the data I need, but it's going to take way more bandwidth and way more time and resources to actually get that to my client. What if we could send just the name? Not even the key, like username : name, just the name, just the thing that's being updated. Often, just sending the HTML ends up being significantly more efficient than building these APIs. And it's not surprising that they discovered this as well. Apparently, it goes further, though, which I'm excited to hear about. Every LiveView holds a connection to the server, so page navigation happens via live navigation. TLS handshakes, current user auth, etc. happen a single time for the lifetime of the user's visit. Whew. This is another really good point. I mentioned earlier that people complaining about server components because of the server costs made no sense. One of the main reasons why is authentication. Let's say I have a web page that has a few parts. We have a top nav. This top nav has like your user icon if you're signed in. We have a sidebar, and the sidebar is generated content based on your user profile, or it's generic content if you're not signed in. And then we have a feed, and in this feed we have some content. And this content is specific to the person who wrote it, username. So we'll put this under here. In order for you to load this page, you would need to get the data for this top nav thing. You need to get the data for the sidebar. You need to get the data for this content section. If I did all of this on client side, I'd be making multiple API requests. So we'll say that this one is /user/get profile or something. So this one, we have to get the profile to render this. We have the side nav, which we'll say is /user/get recommendations, we'll say. And then we have the request here, which is /user/get, we'll even say get permissions. We'll say that this content might not be renderable unless you're authenticated, and we would want to load something else if you're not. All of these are different requests that we would need the ability to make independently. Because if I navigate, I don't need to fetch the profile again in order to fetch the side nav. A lot of people are going to look at this and be like, oh yeah, just make one API endpoint that returns everything. But now when I navigate, I have to fetch everything. But when I'm loading this page, I just want these pieces of data. So what most places do is they use something like GraphQL to make all of these calls for them. The issue here, I made this example very specifically to showcase this, is each of these endpoints needs to authenticate the user. So loading this page requires authenticating the user 3 separate times. So your auth service, good luck. That auth service is going to be getting a ton of traffic just to load the page. If loading one page requires 3 to n requests to your auth server, you're fucked. And you can't just skip that either, because if you skip the auth check, then you might be exposing a data that you don't mean to. So every single endpoint you expose has to authenticate, which means every single one of these being hit per render has to re-authenticate. With server components, a lot of this goes away because you stream the content in. So you can do one auth call, stream the initial response, and then stream the rest in over time, which makes things significantly less painful, which often also results in the server cost being way lower because the IO on top of all of these pieces as well, not just the auth, but the dealing with the request, generating a response, handling the parallel nature of all of these things, connecting to your database if you have to do database connections, parsing and validating the input, making sure it's from a region that you're actually like willing to return traffic from. The amount of shit you have to do on every single request that your page makes is absurd. So if you can lower the number of requests your page is making, things get a lot better. And one of the best ways to do that is serve everything through one request, either by giving it to you immediately when you load the page or streaming it over time. And the way server components does this is you get the first response as quick as possible and the rest streams down as you get more and more responses, as more and more of the content is generated. The way Phoenix handles this is just keeping you in a WebSocket connection where they've already authenticated your your instance. Really cool stuff. This allows page navigation to happen via a single WebSocket frame and fewer database queries for any client action. Yes, it's so nice having a community that isn't the React world explaining why this matters, because I feel like when I talk to most backend developers about this, my brain's about to fall out because they don't seem to understand the fact that your service is getting 10 times the requests it needs if we just slightly adjust the relationship between the client and the server. This should be the default. And the fact that it isn't is a thing that shouldn't be contentious. We should feel slightly ashamed that this isn't how we're doing all of these things. Ugh. The result is fewer round trips from the client and simply less work done by the server. This whole paragraph, by the way, could just be about server components. It's great. The only difference is that this is for the lifetime of a user's visit versus the page load, because the next navigation we're going to have this problem again. In Elixir, in the Phoenix LiveView world, it's just one instance, and no matter how much navigation you do, you're good. So cool. Holding a stateful connection comes at the cost of server memory, but it's far cheaper than folks expect. Again, fair point, since we're maintaining a connection between the server and the client, now we have to worry about the fact that the server and the client are scaling in this way, where the server, if the client is left open, the server now has to manage that in memory. It's a realistic concern. Let's hear why we don't have to worry. At a baseline, given a channel connection consumes about 40 kilobytes of memory, that gives a 1 gig server a theoretical ceiling of 25,000 concurrent live views. Of course, the more state that you store, the more memory you consume, but you only hold on to the state that you need. We also have stream primitives for handling large collections without impacting memory. Elixir and the Erlang VM were designed for this. Scaling a stateful system to millions of concurrent users isn't theoretical. We do it all the time. See WhatsApp, Discord, our own benchmarks as well as examples. This is very true. I will say that 25,000 users per gig of server memory isn't great, but is a fine starting point. If this was in any other language, I would be much more concerned, but Elixir and the power of the Beam VM is insane. It's just like, it's a dumb, simple example, but you can share a namespace across servers in Elixir and Erlang because the Erlang VM is so powerful on the networking side that I can just call a process from another server. It's RPC, but it's RPC that's so deeply baked into the virtual layer that you don't think about it. You just do it. It's like the opposite of serverless, but it comes with a lot of the same benefits. Like, I would never want to scale a system that wasn't either written via entirely serverless patterns like Lambda or was written on top of the Erlang OTP and the Beam VM. Another language that's similar to this, if for some reason the functional patterns that you're seeing here aren't your thing, Gleam is another language built on top of the Erlang OTP. So you get all of these same benefits, just in a slightly different syntax. Super cool stuff. It is similar to Elixir for sure. Very inspired, but they're different languages. Pumped that it exists. Check out my video on that if you're curious. With the programming model optimized on both client and server, we expanded into higher level building blocks that take advantage of our unique diffing engine. Oh boy. Reusable components with HEEX. Oh, this was such a pain point when I was using this. Components were not really a thing in the Elixir HTML syntax. Change tracking and minimal diffs were groundbreaking features, but our HTML templates still lacked composability. The self-awareness, why can't... Imagine a world where more of the backend devs building these types of tools actually understood the way that developers worked now. This is the first time I've seen a backend heavy thing that isn't written in JavaScript acknowledge the value of composability inside of React components. They love to pretend it doesn't matter. They really love to pretend it doesn't matter or just ignore it. And here we are with real server focused developers building a real server side framework, not just acknowledging, but desperately seeking to replicate the benefits that we experience in the React world every day. This is so cool. I know I've been saying this and hinting at it throughout, but I have so much respect for the Elixir team for not pretending that their shit doesn't stink, for looking across the world, seeing how these problems are being solved in other places and using those solutions to better themselves rather than pretending that they're not actually good. This is whatever the opposite of old man yells at cloud is. And it's so nice to see. I just feel a sense of relief as I'm reading this. The best we could offer is partial-like template rendering, where a function could encapsulate some partial template content. The number of people who have pretended that this is the same thing as components. Thank you for calling out the difference. This works, but it composes poorly and is mismatched in the way that we actually write markup. Fortunately, Marlis from the Surface project spearheaded development of an HTML-aware component system and contributed it back to the LiveView project. With HEEX components, we have a declarative component system, HTML validation, and compile time checking of component attributes and slots. HEEX components are just annotated functions. They look like the following. Def button, H button, type is at type, class rounded, yep, again, well, the tailwind works really well with composable component systems. And we have the render slot, which is what we're rendering inside of it. We define all of these attributes ahead too. Type, string, default, nil, rest, global, include, disabled, form name values, slot inner block, require, true. So this means you have to pass it an inner block value, and if you don't, then it doesn't render. Good stuff. Button send, button phx, cool. I think they're using the dot here as their syntax for calling a component instead. An invalid call to a component like button click equals bad produces a compile time warning. Warning, undefined attribute click for component app web core components button. Really nice. Also, generally, the errors in Elixir are really good to the point where I didn't feel a strong need for type systems at the time. Obviously, it would benefit a lot since, but yeah. Slots allow the component to accept arbitrary content from a caller. This allows components to be much more extensible by the caller without creating a bunch of bespoke partial templates to handle every scenario. Yeah, really nice. Don't want to go too deep into this next part, but if you're interested, definitely check it out. They let you spit inside of your actual code here, like your HTML, comments that tell you which files in your code base this was generated by to make debugging much easier. I just filmed a video where I complained a lot about Next not having good enough dev tools for debugging the server-client relationship. This is a really beautiful hack. Just dump in the HTML where it came from when you have the debug flag set. This is super handy. I would use the shit out of this. That's really cool that they're thinking to throw that in here. If you find the above hard to navigate, you can use the new Phoenix.live reloader features that have your editor jump to an element's nearest caller or definition file line when clicked with a special key sequence of your choosing. Let's take a look quick. Cool. That's really cool. You can just click the button and it will bring you where in the code base it was rendered. These things are so hard to set up properly. The fact that they did is nuts. Also, because he's using Vim here. If I recall, Chris is a big Vim guy. So having that work there, that's nuts. Then again, is a Vim user really going to use their mouse? Interactive uploads. Okay, are we competing now, sirs? We should chat. I would love to get upload thing support in LiveView and just in the Phoenix Elixir ecosystem as a whole. A few years ago, LiveView tackled the file upload problem. Something that should be easy has historically been unnecessarily difficult. Woo! Why is this just like, this feels like I wrote it 5 years in the future. It's very strange. This is like an alternative timeline for me. And we wanted a single abstraction for interactive uploads, both for direct to cloud and direct to server use cases. With a few lines of server code, you can have file uploads with drag and drop, file progress, selection pruning, file previews, and more. More recently, we defined an upload writer behavior. This gives you access to the raw upload stream as it's being chunked by the client. This lets you do things like stream uploads to a different server or transcode a video as it's being uploaded. Woo. Since the uploads happen over the existing LiveView connection, reflecting the upload progress or advanced file operations becomes trivial to implement. That's hilarious to me because making file progress it's been blocking us from React Native for a while because the existing bindings for React Native input don't give us the loading states that we need. They're just broken. It's hilarious how hard these things were to do. Pre-signed post has helped a lot, as Josh just mentioned in chat. Before pre-signed post, uploading to the server was so ass. Yeah, it was the worst. It still sucks, but it was even worse before somehow. Super cool to see them making this that easy. Streams and async. Following uploads, we shipped a streams primitive for efficiently handling large collections without needing to hold those collections in server memory. So you have an expensive operation that calls out to an external service. The result can be latent or spotty, or both. Your LiveView can use assign async to offload this operation to a new process and async result to render the result with each loading success or failure state. That's really cool. This is like suspense in React for those who are familiar with the new model. In this case, we have the async result. When it's loading, we render that. When it fails, we render this. And then we have the catch-all, or not the catch-all, but the final correct case where we just dump the org name once it comes in. Now, instead of worrying about an async task crashing the UI, we're carefully monitoring async ops while updating the template with a bunch of conditionals. You have a single abstraction for performing the work and rendering the result. As soon as the LiveView disconnects, the async processes are all cleaned up, ensuring no wasted resources go to UIs that are no longer around. That's another cool benefit of the WebSocket that I hadn't really thought of is, once they disconnect that you can kill whatever was going on based on their process, and the way Elixir and Erlang specifically isolate processes. That makes a ton of sense for. So cool. It feels so React-y. LiveView goes mainstream. Did not think I would see the word .NET in here. Well, let's see why they put it. LiveView and .NET Blazor both started about the same time. I like to think both projects helped spearhead the adoption of this programming model. Since getting started, the model has been embraced in various ways in the Go, Rust, Java, PHP, JavaScript, Ruby, and Haskell communities. Are there Haskell communities for web stuff? Interesting. Most don't offer LiveView's declarative model. Instead, developers are required to annotate how individual elements are updated and removed, leading to fragile applications, akin to client-side apps before the introduction of React and other declarative frameworks. Again, the acknowledgement of React's value is so nice. So many devs like to pretend these things aren't good. Elixir and Phoenix aren't pretending that React is behind them. They're working hard to catch up. It introduced new groundbreaking benefits on top. Most also lack the optimizations that LiveView developers get for free. Large payloads are sent on every event unless developers manually fine-tune them. React itself liked the idea of putting React on the server so much they shipped their own server components to tackle a cross-section of similar goals with LiveView. In the case of RSC, pushing real-time events are still left to external means. Yeah. Once you need to bring in something that is live updates like WebSockets, React is not trying to help you at that point. You implement it yourself. I would make the argument that for the majority of the web, serving everything through WebSockets probably not ideal because most sites don't update during your experience using them. But if I was building something like Twitter or Twitch, the benefits of this model are obvious and insane. And there's a lot of reasons you should consider Phoenix and LiveView instead of the React server component model. But if you're making a blog or even traditional social media, honestly, the benefits of the server component model are really, really powerful too. I feel like these are the two options. And obviously there's HTMX, which is a cool getting started point as well. This is the furthest I've seen a framework get really pursuing these ideas without just becoming a heavy client-side thing. Let's see what he has to say about React before we wrap up. React, like most, chose different trade-offs because they had no choice. The majority skipped the stateful bidirectional communication layer because most platforms are poorly suited for it. Yep. Most places, most backends, most services, most companies, as well as most technologies, are not well suited for a scalable bidirectional layer where the server has reserved some compute and some RAM and all of these things for a specific user during their specific instance. That's a thing that just most stuff doesn't do well, but obviously we have a good solution here. Elixir and the Erlang VM are truly what make this programming model shine. Nothing else can do this. I fully agree here. And we have only barely discussed our built-in globally distributed clustering in PubSub. These are truly extraordinary features built into the platform that are right at your fingertips. What's next? We encourage folks to try out the 1.0 RC in their application and report any issues or bugs. Check the changelog for breaking changes and to bring existing apps up to speed. Following the RC phase, we'll be continuing efforts around co-located JavaScript hooks, web component integration, navigation guards, and more. You get the idea. Special thanks to all the people who helped make this possible. The Phoenix team, especially Stefan Dish, who has tackled countless LiveView issues for the last several months. This blog post is a masterclass in understanding the ecosystem and meaningfully iterating on it. I will be sharing this blog post with a lot of the companies that I work with in order to help them better understand how to communicate the state of the market that they're competing within. That is awesome. I'm genuinely really excited about what I just read, and I'm going to probably go play with some stuff here after stream. Let me know what you guys think. Am I crazy, or is this stuff as dope as it seems? And until next time, peace, nerds.